There are very many uses of electromagnetism. The ability to switch it on and off, it gives us an element of mechanical control over systems like this. Here, a Hercules magnet with an electromagnet in this end and a piece of magnetic material at that end, there is no attraction between the two until I switch on the electromagnet. Now this is basically just passing a current through the coil which is hidden inside this plastic case. But what I now find is that this electromagnet is capable of holding a considerable load. If I switch this off, stop the current running through it, then what happens is it will release. Now we use this technology in anything that we want to hold back and release. Let's go find an example. Here we have a pair of doors that are being magnetically held open. In the event of a fire, the current to the electromagnet is cut, and this results in the doors being released. At the top, we can see an electromagnet in this strip on the outside and two pieces of magnetic material. When a current runs through this electromagnet, it holds the doors securely shut so that they cannot be opened for any reason. And so this kind of electromagnetism can be very, very useful in doors and security. Another really good use of electromagnetism is in this, the electric bell. In the same way as in the previous example, where there was a current flowing through the circuit, there was a magnetic attraction holding something closed. And then when that current ended, then there was no longer any magnetic attraction, allowing it to be released. The same thing happens with a bell just like this. So you can see when the current flows through, these two electromagnets become magnetized, and it pulls this armature over, and the armature is connected to the hammer that strikes the bell. But in the process of moving the armature over here, it actually disconnects the armature from the circuit. The armature acts like a switch. When it is over to the right, it is no longer connected to the terminal on the left. That cuts the current and that ends the magnetism, and so it releases the armature once more. So as it goes back, it then recontacts that thing, and so therefore the current flows again, and then it all happens all over again in one great big long cycle. Let's press the button. Another really good use of electromagnetism is this, the electromagnetic relay. So what you can see here is there's two circuits going on. There's a simple circuit here with a switch in it that is connected to an electromagnet. All this does is turns that electromagnet on. But you can see that the second circuit, which at the moment is off, is connected to the mains electricity. But what happens is it goes through this very large magnetic strip. Now what happens when that is pressed down is it makes contact and completes the circuit. Now what I can do with this circuit is make the current flow through this circuit, turn on the electromagnet, which pulls the other switch into the open position. So this circuit controls that circuit. Now relays are really, really useful where you don't necessarily want the person in control anywhere near the high voltage electricity over there. I can have a very simple safe circuit operating a much more dangerous one. You may somewhere in your house have a box like this. Inside the box there appears to be a bunch of switches, something to do with electricity. Well, what we saw with the relay is the same principle at work here. Come closer and have a look. Behind each one of these circuit breakers, we have got something very similar to the electromagnetic relay. These are put into the circuit to protect against there being a surge of current. If the current gets too high, then the strength of the electromagnet behind each of these switches gets really strong and has the effect of pulling the switch into the closed position, so that if the current gets too strong in the main circuit, this switch is pulled close to shut it down. This protects our circuits against surges in current. Another really good example of a use of electromagnetism is in the speaker. See, what we have here is two things. We have an electromagnet attached to the cone of a speaker, and that's what these two wires attach to. And then in the base of the speaker we have a fixed magnet. Now, if we put an electrical current through the electromagnet, it's going to be attracted towards the other magnet, like magnets do. But then if we stop that current, it's going to relax and be released from the magnet. If we fluctuate the current at just the right frequency, we can actually have that electromagnet pushing back and forwards. And given that the speaker cone is attached to that electromagnet, it will have the effect of making it pulsate forward and back. You can see it is jumping back and forward. Now this at very high speed is the thing that produces the frequencies of sound that we can hear. You can just about hear that. It is now vibrating so fast that it is almost too fast to see with the naked eye. Let's do a different note.